Yeah, fourth module is all about data link layer. And we studied in the last module about, that means last chapter in third module about error detection, right? Error control methods, right? So this is also, I mean, error methods or the error control is one of the functionality of data link layer. We studied CRC, right? Cyclic redundancy check as well as internet checks, right? So those methods are used in data link layer. So you can see error control is one of the functionality of this data link layer. Okay. And in this chapter, I mean, in this module, you have 4 chapters. Okay. Uh, I mean, all 4 chapters is about data link layer itself. And all these chapters are very small. Uh, we can finish it off soon, but let me give you assignment so that you can be thorough with all the concepts. Okay. And this module includes first chapter is all about data link layer services, sorry, data link control services, and the second one is medium access control. Fourth one is introduction about the data link layer, and the last chapter is about addressing. So in addressing, we will be studying, addressing, this is with respect to network layer, and here we'll be studying about the details in addressing. Okay. So let's start with the first chapter, that is data link control services. So before starting data link control services, I just want to remind you the functionality which we studied uh, for the data link layer in the first module. So what are the data link layer functionalities? We discussed many functionalities, right? One, as I said, it is error control, right? So before looking into the functionality of this data link layer, you need to remember the data, what protocol data units, or the data units used in each layer of the network. Okay. So since we are talking about data link layer in this module, you have to remember what is the data unit used for the data link layer. As you can see in this image, which the what layers are 7, right? With respect to TCP/IP network model, the layers are 5 layers: physical layer, data link layer, network layer, transport layer, and application layer, right? So data is generated at the application layer, so that we call it as message, right? And then this message is passed on to the next layer, that is transport layer, where this message will be divided as here segments, as you can call this as a data unit of this transport layer. And then again the segments are for transferred to the next layer, that is network layer. Here we call the data as a datagram, right? And then forwarded to the transferred to the data link layer, where we call the data as a frame. Okay, the packet whatever created at the network layer is divided as frames, and then this data link layer forwards the data in frames in the form of bits to the physical layer, right? So then this physical layer converts the bits into what signals, and then transmitted over the transmission link. So with respect to this data link layer, you have to remember the data unit used for this layer is frame. Okay. So let's see what are all the functionalities of this data link layer. The first is what? Framing. I mean, what the data which is received, or the packet which is received from the network layer to the data link layer, the packet is divided as frames. So where that process we call it as framing. This is one of the functionality. And next, flow control, then error control we already discussed, and the last one is access control. So we are going to study all this. Okay, these are the functionalities of data link layer. Okay, so Framing. In the framing, uh, as I said, what is framing? We have already discussed this in the first module. Okay, here you can see this. One second. Yeah. So yeah, the packet is received from the network layer, right? Packet is received from the network layer. For this data, you are going to append header and the trailer. Okay, so this all together we call it as frame, right? So this process we call it as framing, and then that frames is passed on to the next layer, that we to the next layer, that is physical layer, right? So framing is what? Adding header and the trailer. Okay, so let's see how it is done in this layer. Okay, so framing is of two types. Okay, uh, fixed size framing, and the second one is variable size framing. Okay, framing follows two types: fixed size framing and variable size framing. Fine, let's see the first one, that is fixed size framing. What is fixed size framing? That means the packet which is received from the network layer, okay, is divided as frames, right? So that means what? The division, whatever takes place on the packet, will be of fixed size. Fine. So let's see. Uh, for example, you can see here. If have if I have a packet of 101 bytes, okay, this is the packet I received it from the network layer. Okay, so this packet I have to divide it into frames, and the size of the frame is fixed. Uh, let's see, size of frame is 10 bytes. Okay, so how many frames it will form? It will form 10 frames, right? And each frame is of same size. Okay, say 10 bytes. Okay, 10 into 10, 100. And the last one, consider here, it is dot dot dot. Okay, 10 frames. Okay, and the last one, this is also 10 what 10 bytes. Okay, so but it will take only one byte here, right? Last byte will have only data as one byte, and whatever the left out 9 bytes are there, that will be what uh, included with the stuffing. Okay, so that extra 9 bytes will be considered for stuffing, because each frame size should be a fixed one, right? So this packet is divided into number of frames, and each frames will have fixed size. Okay, if the last byte is not the data is less than the uh, size of the frame, then the left out space need to be filled with stuffing. Okay, the stuffing will study in the next topic. Okay, as syllabus progress in this module, in the first chapter only, we'll study the stuffing. I hope this is clear. So what is fixed size framing? It is fixed size framing. There is no need for defining the boundaries of the frame. The size itself can be used as a delimiter. That means all the frames will be of same size. Okay, so if the extra space is available in the frame, then that you have to stuff it. Okay, that is all about fixed framing. Now, second type is what? It is variable size framing. As name says, the size of the frame varies, right? So here, let me consider this example. Okay, so the same, let me consider the same packet, say the packet which is received from the network layer. The size of the packet is 101 bytes, and for this data link layer, we are following variable size framing. Okay, so here again this packet will be divided into number of frames, and each frame will be of different size. Say this may be 15 bytes, and next one maybe uh, 8 bytes. Okay, next one maybe 50 bytes. Okay, and so on. So here so the size of the frames is not fixed. That's why it is called as variable size. I hope this is clear to everyone. In the fixed size framing, all the frames will be of fixed size. In variable size framing, the frames that is formed at the data link layer will be of variable size. It is not fixed. Okay, so that's why it is called as variable size framing. So if the frame is variable size, then we need a way to define the end of the frame and the beginning of the next, right? So this is this you have to mention it. Say, see, this is variable size, right? Say this is, as I said, it is 15 bytes. Okay, as this you take it as 5, and this as 50. Okay, so the receiver will not be knowing where this particular frame ends and where the next frame starts. Because here there is no fixed size, whereas in fixed size framing, since the size of all the frames are fixed, receiver will easily identify what is the starting of the frame of the next second frame. What is the starting of second frame? That means what is the starting of each frame and what is the ending of each frame. But that is not the case in variable size. Okay, because the size of the frame varies, right? So it is very important to mention what is the starting of the frame and what is the ending of the frame, or what is the starting of second frame and what is the ending of second frame. So to do this, we use delimiter. What do we use? We use delimiter. Say, what is delimiter? Extra byte is appended to the frame. So this says this is the starting, okay, and this says this is the uh, end of the, sorry, this is end of this frame. Okay, so in this way, for each and every frame, we are going to append the start of the frame and end of the frame. For this also, the start of the frame is required and end of the frame is required. So looking at the start and the end frame bytes or bits, the receiver will come to know this is the beginning of the particular frame and this is the ending of this particular frame. Okay, so the delimiters are not required with respect to fixed size framing. Okay, so let's come back to the topic. So now, to do this, to mention what is the beginning of the frame and ending of the frame, we use two approaches, that is character oriented approach and bit oriented approach. To mention the starting of the frame and the beginning of the frame in variable size framing, we follow two approach. One is character oriented approach, another one is bit oriented approach. Okay, so let's start with the first one, character oriented approach. Okay, so here you know how frames are formed, right? The header and the trailer will be added to the data, and this we call it as a frame now, right? The adding header and trailer is nothing but encapsulation, right? And removing the header and trailer at the receiver end, we call it as decapsulation. We studied this in the first module, right? So what is there in the header part? Header part, it is information that is required for the receiver to process this particular data. That is maybe source address, or it may be destination address, or some other controller information that is required for the receiver to process the data. Okay, so that is encapsulation happens at the sender side, and decapsulation happens at the receiver side. Okay, so now the character oriented protocol. Okay, this is why it is done, to specify the starting of the frame and ending of the frame. Consider this is the frame. Okay, so from header till trailer it is a frame, where since it is a variable size framing, you need to have this beginning of the frame and ending of the frame to say that this frame starts from here and ends at here. Okay, so header, as I said, it is the information required for the receiver to process the data, whether it may be source address or destination address. Okay, whereas trailer, what does it includes? It includes the redundant bits that is used for the error control. We studied in the previous model, right? The redundant bits added to the data that we are going to include in the trailer, so which helps in error control. So this may be CRC, that is cyclic redundancy check, where CRC is formed after the division of the dividend with the help of divisor, whatever the remainder remains at the end, right? So that CRC is included at this trailer. Okay, or if you take internet checksum, the checksum that is formed at the end of the process at the sender side, that data is, that bytes or the bits are included in the trailer part. Okay, so that is all about trailer. So header includes the information required for the receiver to process the data. This may be source address, destination address, or any other control information. Whereas trailer, what it includes? It includes redundant bits with respect to error control. It may be CRC or checksum data. Okay, so now uh, this flag this flag represents the beginning of the frame, and this flag represents end of the frame. So what the data from after header before trailer, this thing we call it as data. Okay, and as I said, it is a variable size framing. So the data which is present here will be of variable variable size. And one thing you have to remember here, each whatever the cells that are considered here must be of length of the value which has to be multiplied by 8. See, uh, this may be of 8 bits, this may be of 16 bits, this may be of uh, 32 bits likewise. Okay, so all data must be of multiples of 8, or this must be divisible by 8. Okay, so if you take the flag, even this must be multiples of 8 itself. If you take header, even this also must be in the form of multiples of 8 only. Okay, so that means whatever flag, header, data, trailer, again flag that you consider here will be in the form of bits itself. Okay, so 1 byte is what? 8 bits, right? So if I say this is of 2 bits, 2 bytes, then it will be of 16 bits, right? So whatever the size that we consider for flag, header, and the data, it should be of multiples of 8, or it has to be divided by 8. Then that way of formatting is followed in character oriented protocol. Okay, so I'll just repeat it here. The variable size framing is used. Okay, So header and trailer will be included for the data that is received from the upper layer, for which the flags are added to specify what is the starting of the frame and what is the ending of the frame. And here, as I said, what each flag or header will be of the value that is multiplied by 8. Okay, the flag is of 8 bits. Okay, and header will be of multiples of 8s, or it has to be divided by 8 itself. Okay, so that is all about character oriented protocol, or you can say byte oriented protocol. Okay, do remember, the header and trailer is included for the data, and flag is also appended to specify the beginning of and ending of the frame. Okay, and next method is bit oriented protocol. Bit oriented protocol. See, as I said in the previous method, here all the fields are will be in the form of bytes, which is nothing but 8 bits, right? Or multiples of 8, right? So whereas in bit oriented protocol, everything will be represented in the form of bit itself. Okay, the same thing. Here there is no restriction that the size of each field has to be divided by 8 only. There is no fixed rule here. Okay, so here this may be of 15 bits. Okay, or this may be 18 bits likewise. Okay, the size of the field is not fixed here. That means it should not be the multiple of 8. Okay, the way the size, sorry, what in bit oriented protocol, the size, it is not necessary it should be multiples of 8 itself. Okay, that is about bit oriented protocol, right? And so just difference is that here it is expressed in the form of 8 bits. All the field must be of 8 bits. Whereas here in bit oriented, it is not the case. Okay. So variable size, I mean, it is not mandatory to have the bits followed in each field has to be divided by 8 itself. Okay, so next the thing is, as I said, all flags, header, data, everything will be in the form of bits, either 0 or 1. 0 and 1's patterns are followed here, maybe in the place of flag, maybe in the place of header, or in the place of data. Everything will be in the form of zeros and ones. Okay, so now the thing is, here there is a problem with respect to character oriented protocol as well as in bit oriented protocol. That is, see, here flag is used, right? So if this flag is say, let me consider, yeah, flag here followed is 0 1 1 1 0 0, say, let me consider 4 5 6 7 8, okay, 0. Okay, so this is the bits that is present at the flag here with respect to character oriented protocol. Now, as I said, the data which is present here is also in the form of bit pattern. It follows bit sequence, right? What if and one more thing, whatever the bits followed uh, at the place here flag is same as the bits followed at this flag also. If it here the bits considered as 0 1 1 sorry 0 1 1 1 1 0 0 0, the same bits will be present at the flag also. 1 0 1 1 1 0 0 0. Okay, so when the receiver receives this, Okay, first he'll check, okay, this is the what starting of the frame. These are the bits present here. Then he'll open header part and then he'll see, oh, okay, this frame is received from the sender side and I'm the destination where data has to be delivered. And then he'll receive the data here and then he'll see the trailer part where error check will be done, and then he'll encounter this flag where again the second time the same bit pattern is repeated here. So this says this is end of this frame. Okay, so now what happens, the problem with respect to this method is that here whatever the bits that is present here, if it is repeating in the data, okay, somewhere here, if the data which is presenting here is the same as the flag that is considered for this frame, if this is the bit stream which is present in the data, then receiver will think that, oh, second time I'm encountering this bit pattern, so this is the end of the frame. It is a wrong way of processing the data, right? Actually what it is, what frame will end at this point, not here. This is the data. The receiver has to treat this also as the data. This is the data, so he has to consider this as the data, not as the flag. Okay, not as the end of the frame. Okay, to overcome this problem, such problem, we follow byte stuffing. We follow byte stuffing. What is byte stuffing? It is the process of adding one extra byte whenever there is a flag or escape character in the text. So whenever the bits considered in the flag is present in the data, then one extra byte is added to solve the problem which we discussed in the previous slide. Okay, so the receiver has to treat, if flag bits are present in the data, then receiver should treat that as a data itself, not as a flag. Okay, so let's consider this example. Oh, 1 second. Yeah. Okay, one extra byte will be added. Okay, let's see that example. So now consider this is the frame. So this whole thing is a frame. Okay, so where flag is also present, header trailer is also present, and in between data, actual data is present. Okay, so now consider the data is received from the upper layer. Okay, this whole part is data now. From here till here, it is data. So as you can see here, there is a flag in the data. That means the bits used in the flag is the same pattern as present in the actual data also. Okay, now it's the duty of the receiver. Okay, it is the duty of the receiver to not to treat this flag as a flag, but he has to consider this flag as the actual data. Okay, so to solve this problem, you can see here one extra byte is added, that we call it as escape character. Okay, so then it is delivered to the receiver, where receiver will think, since one before the flag escape character is present, so he'll think that the flag bit, whatever the bit stream present here, is the actual data, not as the flag. Okay, this escape is nothing but one byte, right? 8 bits will be there. Again it is 0 and one bit pattern. Okay, that is one condition. Next, what if the bit pattern followed for the escape is present in the data itself? What you have to do in that case? In that case also, the receivers should treat this pattern as data itself, not as the escape character. Okay, so to solve this problem, we again include escape character, that is one extra byte. So this escape character will say that this escape is not the escape character but actual data that is received from the upper layer. Okay, so this will solve the problem which we discussed in the previous line. So now if the flag is present in the data, you can the receiver should treat the flag as the data itself. To solve this problem, escape character is used. Another problem is whatever the bit pattern followed for the escape is present in the data only, then again for which you have to include one more extra byte, that is called as escape character, so that this escape should be treated as data itself. This is done at the sender side. Okay. Now at the receiver side, what happens? He'll receive the frame. He'll opens this. Okay. He'll open the frame. This specifies the beginning of the frame. Header information will be checked. Okay. And then he'll see escape is there. Okay. Whatever the data followed by this should be treated as data itself. Okay, and then again one more escape is there. That means after this, whatever data is present, that should be treated as data only. Okay, so and then trailer will be checked, and then flag will specify the end of the frame. Okay, this is how byte stuffing works. Okay, so what we discussed the functionalities of data link layer, right? And then framing, which is of two types, fixed size framing and variable size framing. And then character oriented protocol followed under variable size framing, where we studied flags are added to specify starting and ending of the frame. Then bit oriented protocol is discussed, and then byte stuffing is topic is discussed in this class. Okay. Yeah. Oh, one second.